Okay, so we're going to look at factoring trinomials where a is larger than 1. So a little review, here are trinomials where a is 1, here and here. And then what happens here, a is not 1, but really it is 1 because if there's a non-1 here, like something bigger than 1, I have to check and see, maybe it divides into all terms, and I would start by doing the common factor. So 2 does divide out of all of those. So then we'll have, if I divide everything by 2 to divide out that common factor, I'll get a squared plus a minus 12, right? And then we can look at this and say, well, a really is 1 now. Now I can just factor this trinomial where a is 1. Let's do a quick review of that. I'm going to change these to x's just so it doesn't get confusing with all the a's that I'm going to be talking about here. All right, so remember the coefficient of x squared, that's going to be a. The coefficient of the x will be b, and then the constant term will be c. So we want factors of c. So that are things that multiply to negative 12. So in this case, it's negative 12. I'm going to go with 1 and negative 12. Those are some factors that multiply to make c. I can go with negative 1 and 12. I can go with 2 and negative 6. I can go with negative 2 and positive 6. So I alternate the negatives because these all multiply to negative 12. Right? Remember, I'll write it up here. We're trying to get numbers that multiply to negative 12. Then we have 3 and negative 4, and negative 3 and positive 4. Those all multiply to negative 12. But now we want to find the ones that add to b. And b in this case we said was 1. I'll write these down. A was 1, b was 1, c is negative 12. Okay, so now I got to add all these up. So if I do 1 plus negative 12, I get negative 11. And that does not add up to 1. This one here, I get positive 11. 2 minus 6, I get negative 4. Negative 2 plus 6, I get positive 4. 3 minus 4, I get negative 1. Negative 3 plus 4, I get positive 1. That's our winner right here. So negative 3 and 4 is how this factors. X minus 3, x plus 4. And then we have to remember to bring down that common factor as well that we already factored out. So a quick review of trinomials where a equals 1. And this example is good because when you first look at it, you think, oh, wait, a is not 1. I can't do this method. But first, you should always try common factor. It factors out. And now, look, a is 1. Today, we're going to look at what if they don't factor out. Okay, so here's an example we're going to look at today. Here's a trinomial. A is not 1, and 2 does not divide into all of these. So now we have a new method for this, a trinomial where a is bigger than 1. Okay, here are the steps. They're pretty similar. Okay, step 1 is similar. Instead of just finding the factors of c, which is what we did up here, we're going to multiply a and c and look for factors of that number. So since a is no longer 1, you have to do 2 times 3. And when we make our list, we're going to do factors of a times c. So 2 times 3. So we're looking for factors of 6. All right? Now, technically, you were doing that for these up here because if a is always 1, 1 times whatever c is will always just be c. So up here, you kind of were already doing a times c. It's just that the a is always 1. So multiplying 1 times this c value will just always make it be just c. All right? So factors of a times c, and then we're going to go for that add to b, which in this case is 5. Sorry, I should have identified these. Remember, a, b, and c. A is 2, b is 5, c is 3. All right, so we're looking for factors of 6. So we're going to go 1 and 6, negative 1 and negative 6, 2 and 3, negative 2 and negative 3. 1 plus 6 is 7. This one sums to negative 7. 2 plus 3 is 5. Oh, I can stop. There's my winner because I wanted 5. Now, here's where it gets different. You can't just make 2. You can't just go straight to your answer with the 2 and the 3. We're going to do something called split the middle term. So right now, there are 3 terms. It's a trinomial. The middle term is the linear term. Remember we called that linear because it's x to the first power? we're going to split that linear term. So that means we're going to keep the 2x squared. We're going to split the linear term into two different linear terms, and we're going to keep the constant. Now, if these are still going to be linear terms, please keep in mind they're both still going to be x. So I always kind of like to make sure it's x and x. And the way they're going to split is you're going to make them these numbers, plus 2x and plus 3x. And you can do it in either order. I'm going to do this first, the order that you should not do. Okay? Because then we have 4 terms, and we're going to factor by grouping, which is that other strategy we learned. So if I group these two together, what do they have in common? If I group these two together, what do they have in common? Well, because I went plus 3 and plus 2, that wasn't a great choice. If I look ahead, I should have done it the other way, because you could switch it either way. I'm going to go plus 2 and plus 3, because now when I do my grouping, I see these have a 2 in common, and I see these have a 3 in common. So it was better to do plus 2 plus 3, but you could do it either way. All right, so now that I've split the middle term, so I just want to show you. We did step 1, we multiplied a and c. Then we found the pair of numbers that are factors of a times c and add to b. That's what this list does. We found that pair. That was step 2. Step 3, use the pair to split the linear term into 2 linear terms. So we're splitting that linear term into 2 linear terms using these guys. 2 plus 3 is 5, so I'm just like unadding that, okay? Now we're on step 4. Now that there are 4 terms, use the factor by grouping method, all right? So that was, we're going to just group these two together and common factor those. So I noticed that they have a common factor of 2x. Then I'm going to group these guys together and look for their common factor. I noticed they have a common factor of 3. Now, you always, when we do grouping, don't forget, you always pull down that sign in the middle. You got to have a plus or a minus there. All right, so now when I do the common factoring on the yellow group, I have to divide out the common factor from each part. So when I divide 2x squared by 2x, 2 divided by 2 is 1. X squared divided by x is x. I'll show you on the side over here if you forget how this works. Remember, 2x squared means 2 times x, and 2x means 2 times x. 2 divided by 2 is 1, so they reduce away. X divided by x is 1, so those divide away, and I'm left with just x. So the leftovers there is x. 2x divided by 2x is 1, because if I have 2x divided by 2x, 2 divided by 2 is 1. X divided by x is 1. So there's my leftovers. I'm just making a video if you give me 1 minute. Okay, and then now that's my leftovers there. Now I'm going to common factor out of the pink part. So I'm going to divide out the 3. So I do 3x divided by 3. That's just going to be x. And then 3 divided by 3 is just going to be 1. Okay, now I have 2 terms because of that plus in the middle. Do they have something in common? Do they have a factor in common? They do. Their common factor is x plus 1 is in both of these. So I'm going to common factor out an x plus 1. Whoops. X plus 1. And then I'm going to put in my leftovers. Well, I do it the same way. I'm going to take the common factor and divide it out of the first part to get my leftovers. And I'm going to divide this part by the common factor as well. So I'm just doing common factor again. Here, these divide out, and I get 2x. Here, the common factors divide out, and I get plus 3. That is our answer. It is now factored because it's multiplication. And that's how you're going to do a trinomial where a is not 1.